Well, good afternoon, everybody. We're back for another video, and really the reason I'm going to do this one is just to have a little bit of fun talking about some of the things that you read about and hear about out there, and a lot of the comments that I've received over the time that I've been doing videos, and a lot that I've read on even other people's YouTube sites. And what always seems to come up again and again and again is comments about amplifier power. Okay, some people saying that this, that, or the other receiver or amplifier is garbage or is great or is whatever. I've had comments about why in the heck go through all this mess and spend all this money on a 10 for just 10 watts or 5 watts, and they get hung up on the word watts. And I did a little video called "What's All This I Hear About Watts?" Little play on words, and you can look it up. It's on my channel here. But I want to expound upon that video a little bit and get a little bit more. I want to do a little bit of a visual explanation of what all this power rating is all about. I want to show you some of the ways that we have been deceived over the years and still continue to be deceived. I'm going to introduce you, if you haven't already heard about it, to some terms that you might read or hear. And then we're going to actually visually look at what it is they're talking about, how they come up with these readings. Okay, so if that sounds interesting to you, stick around, and maybe this will be a fun video to watch. So the first thing I want to show you here is this is an old, probably from the late 60s, early 70s, out of a company that's now defunct. They're out of business, called Lafayette. Now, I don't know, some of you may or may not have heard of this company. And contrary to popular belief, some of the things that this company put out were actually very high quality. But since they misrepresented them for what they were, some of this equipment got a really bad rap. Okay. First thing you need to understand about old gear, anything made in the 1970s, 1980s, and even in the 1960s, a lot of the times the technology they had at the time for making things such as electrolytic capacitors, paper capacitors, and so forth, those did not, they don't last forever. And some of them had a tendency to fail, even fail early, for what they were. And those caused the amplifiers to fail, but those are relatively inexpensive parts to replace and repair, so it's not a big deal. But just know that, some of these things have gotten a bad rap for the technology of the time, but when they were new, they really performed well. The other thing that things got a bad rap for is what I've got right here on the camera in front of you now. Now, this was a receiver called the model LR500T, made by Lafayette. And like I said, this was late 60s, early 70s. You can look, the price was $179.95. And when you look, the first thing you see is it says 60 watt solid state AM FM stereo receiver. Well, everybody knows that more is better. So it didn't take long for the marketing people out there to figure if you put a bigger number of watts on your receiver, it's more appealing to people to want to buy it, because they figure the more watts you have, the louder it is. And really, there's so much more to that than just that, okay? First of all is how they arrive at watts. So we're going to hear a few terms in this video, and then we're going to see what I'm talking about visually. We're going to use an oscilloscope, and we're going to use a meter that should be interesting to show you what's happening. But first of all, let's set the scenario. This receiver is rated at 60 watts. If you look at the actual description, let me see how far I can zoom in without, okay, that's pretty good. 60 watts of flawless stereo output power, okay? And they say some of the good things, you know, it's a 4-gang tuner, and, you know, they give you the sensitivity and all that stuff for the tuner. But when you get down here, this is where it gets kind of crazy. It says amplifier, 60 watts at 4 ohms. Now, is that 60 watts per channel? Is that 60 watts total? What the heck does that mean? It does tell you at 4 ohms at least, right? 50 watts at 8 ohms. Frequency response, but it doesn't say that it's flat, and I'll get into that later. 22 cycles, or cycles per second, to 20,000. Okay, so that's the full range of hearing for the most part. Our ears, the perfect healthy young person ear, not Tony ear, we've had that discussion on my videos before. You can hear from about 20 hertz up to about 20 kilohertz, you know, and different people have different ears. There's people that can even hear outside of those ranges that have really, really good hearing. But the general consensus is the average human healthy ear can hear between those frequencies. So it says that this amplifier can reproduce those frequencies. Rated, okay, it says HD, and actually I believe the letter I is missing there. It probably says IHD or something like that. Or HD just meaning harmonic distortion, I think. Okay, at rated output is less than 1%. So it doesn't give you the exact distortion, and they're not really talking about still what their rating is. Okay, now keep that in mind. We're going to move forward in their little catalog. This is their next model up, which is the LR1000. Okay, so let me zoom back out. Here is the LR1000. Looks very similar. If you look to the, you know, they're very similar looking receivers, almost identical, you know, other than an extra jack there, a couple things. But this is their next model up, and we jump from a 60 watt to a 120 watt. Okay, and if we look at the specs on this, all right, they're all blurry now. Okay, so if we look at the specs here, amplifier 120 watts at 4 ohms and 95 watts at 8 ohms. Frequency response is the same, and distortion at rated output is 1%, and intermodulation distortion at rated output is 0.4%. Okay, then it says bandwidth. Okay, so it says frequency response is 22 to 20 kilohertz, but the bandwidth is 20 to 40 kilohertz. What the heck does that mean? Okay, we'll talk about some of these things here in a minute. Moving forward, we have our next model. It is the LR1500, and actually this particular model among audio people is somewhat respected. It's not a bad receiver, but it gets a bad rap by people because of the way that Lafayette marketed it. Once again, 175 watts. Do you realize how big that is? Do you realize what I had to go through in this, you know, my last video on that 205 watt receiver, and even some of the Pioneers and the Kenwood and, you know, all the different receivers you've seen on this channel? None of them were rated like this, right? And they were all physically much larger. I mean, these receivers are quite small, believe it or not. I don't know if they actually give you the physical dimensions. If you look at the physical dimensions here, just to give you an idea, it's only 16 3/4 of an inch wide, 4 5/8 inch tall, and 14 1/4 inches deep. And it weighs 43 pounds is the shipping weight, which means that's the containers and everything. So you figure about 40 pounds, but which is relatively heavy. That, I'll give it to you. That's a heavy, you know. But you can see it's a relatively small receiver. So for 175 watts, just right there is already kind of my eyebrows raising a little bit. And if we look at their ratings, they're saying 175 watts, and now all of a sudden, they didn't put this in the other ones, but in this one, now they're using a term. I want you to look at this very carefully right here. IHF. Okay? Extremely, extremely important that you look at that word. IHF. 175 watts IHF at 4 ohms, 120 watts at 8 ohms, distortion at rated power under 1%, frequency response 20 to 20 kilohertz, bandwidth 12 hertz to 40 kilohertz. Okay, so that's what I call, and I'll explain it here in a minute, that these are what I call deceptive marketing tactics. Okay, and why will become clear here as we do this video. Now, the next thing I want to do is I want to give you, this is the printout of the Radio Shack, which one is it? The Model 64, STA-64. I had a little bit of a brain fart there, sorry guys. So the STA-64 receiver, this is the one we just did the did the restore and the repair on, if you recall. And I got I've heard some comments on on some of the audio websites and things. Radio Shack makes garbage, and their stuff is junk, and it's not rated right, and they just they're made out of garbage parts. And well, let me tell you something, that was a pretty well designed amplifier that performed very well, and it lived up to its reputation of what it was advertised as. And look at the way they advertised this receiver. Audio output power at no more than 0.8% total harmonic distortion into 8 ohms, so it's 8 ohms they're rating the power, over the audio spectrum 20 to 20 kilohertz. Okay? So what they're saying is, all the way from 20 hertz to 20 kilohertz on an 8 ohm load, they're guaranteeing you that you will get 16 watts, okay, per channel, both channels driven. That means I'm running the signal into both channels at the same time, so I'm loading the power supply maximum, and it is the minimum RMS, not IHF, RMS power with both channels driven. So this is the minimum that you can expect out of this receiver if you test it, no matter what frequency you are between 20 hertz and 20 kilohertz. Okay? And they're saying if you do just a single frequency test at 1 kilohertz, it will produce 22 watts per channel with less than 1%. And the total frequency response is 15 to 30,000 hertz. Okay, let's break this down. Okay, go back to my STA-64 video. If you look, the first thing I tested was 1 kilohertz. In other words, I had a 1 kilohertz sine wave that I put into the receiver, into the amplifier, into the auxiliary terminals. And I drove it into full power till it started to clip, till I started to see some visible distortion on the waveform. And lo and behold, if you look at my results, okay, we were getting somewhere in the 21 to 22 watt range. Okay. And then if you notice, I also tested it at 20 hertz and 20 kilohertz. I think I did on that video. If I didn't, I apologize in advance, because I didn't go back through and look at my video to verify what I'm telling you. But I did test it, whether it was on camera or off, I can't remember. But I was able to get that 16 watts even down at 20 hertz, which is very hard because low frequencies are harder for the amp to reproduce than the higher frequencies or the mid frequencies. And it stayed nice even sine wave, even at 20 hertz, at 16 watts. Now I couldn't get that 22 watts, and that's what this is telling you. Okay, so the amp isn't totally flat. Okay, totally flat meaning it won't vary the output based on what frequency. Okay, so if you notice, I never varied on my signal generator how many volts input. So if I did 1.5 volts of signal into the auxiliary jack, okay, and all I did was varied the frequency, okay, my output was always, okay, 16 watts where I would start to get my distortion. That means the amp is very flat at 16 watts. If I keep my power rating around 16 watts, I can get a clean, undistorted 16 watts at any frequency. With this, if I want to max it out till it clips, at 1 kilohertz it'll clip at 22 watts, and at 20 hertz it clips at about just above 16, so it'll just barely make this rating, but it makes it. Okay, so that's this. What they're saying is the specifications here are very, very honest. I was able to look at this on an oscilloscope and reproduce this exactly as they said. Okay, and that's what we're talking about. Now this RMS and IHF, I'm going to get into that here a little later, I promise. But let's go to one last example. If you recall, I did a couple of videos on a restoration of a Pioneer SX-750. And what I've got here is the actual specs of that SX-750. Again, continuous power output from 20 hertz to 20 kilohertz with both driven, and it's saying that it can produce 50 watts per channel into 8 ohms and 60 watts per channel into 4 ohms. Okay, now I know what you're all saying. If you look at the voltage that amp can put out and you do Ohm's law with a 4 ohm resistor, I should get a lot more than 60 watts, but these amps are current limited on purpose because they're really not designed to handle, they may handle the voltage, but they can't handle that much current into that small of a load. So that's why this is rating at 60 watts. That's another whole thing to get into on amplifier rating, but just a little note on that so you understand, okay? Total harmonic distortion at the continuous rated output, no more than 0.1%. So this is a very low distortion amplifier. It's a very clean sounding amplifier. Okay? And then they rate it even lower, so if you're running it only at half of its power, 25 watts per channel into 8 ohms, that distortion drops even further. Now, I can't hear the difference between 0.1% and 0.05%. I'm sorry. I'm sure there are those of you out there who can. And I wouldn't doubt that you can, again, if you have those kinds of healthy ears to do such a thing, and you listen to a lot of different music for over a long period of time, and you train yourself to hear the nuances like that, I'm sure you might be able to hear that. Me personally, I can't. Okay, it all sounds good to me. Till you get up over that 1% mark, that's where you start to, even an untrained ear can hear distortion like that. But anyways, at 1 watt per channel, it's the same. I mean, the limitation is the electronics now, not, power or anything like that. And then they give you all kinds of different things. Damping factor, damping factor, I don't want to get into a big dissertation on that for this video, but damping factor is actually the ability, it's the ability for the amplifier to dampen the speaker. And I think I showed you that a little bit on my What's This All About Watts video, where if I take a speaker and I thump it with my fingers, it makes one tone, that's kind of rings a little bit, and then if you short out the speaker terminals, the speaker kind of acts, that coil acts like a brake, and it actually dampens the speaker, and that ring turns into a dull thud. Okay, if an amplifier has a very low resistance that it presents to the speaker, it can dampen the speaker better than if it has a higher resistance. Okay. Okay, and so the damping factor, basically the higher this number, the better the amplifier's ability to dampen the speaker when it's not presenting a signal to the speaker. Does that make sense? I hope it does. I mean, if you look online, there are big, huge descriptions of damping factor and how to calculate it, all kinds of different things. You can really get into that if you want. Suffice it to say that, you know, the higher the damping factor, to a point, above a certain point, when you start looking at damping factor, you know, a damping factor of 10,000 or some ridiculous number isn't going to make that big a difference from a damping factor of 200, let's say, or something like that. I'm just making up some arbitrary numbers. But up to a certain point, you know, anything from 30 to 50, 30 to 70 is a decent damping factor. Conversely, because vacuum tube amplifiers have an output transformer, that coil itself tends to not have an extremely low DC resistance. So usually vacuum tube amplifiers have relatively low damping factors in the line of 10 or 12, you know, and yet some of them sound extremely good. But if you notice, a lot of times speakers will tend to flutter more on a tube amplifier because of that. So just a little to let you know. But that doesn't mean that you can't have a good sounding tube amplifier, because as you all know, some of the best sounding amps out there are vacuum tube driven. Okay, anyways, back to this. So what we're trying to describe here is that there are honest ways to rate an amplifier, and there are less honest ways to rate an amplifier. Okay. Now, before I get into RMS and IHF and all that stuff, I would like to give you a little idea of what I mean by power. Okay, so here's a little printout I did of watts, rated watts, and this is, again, when you start dealing with decibels, there's all kind of conditions that goes with it. Okay, so watts across a given load. Okay, so this could be watts at 8 ohms, watts at 4 ohms, but just so every one of these are all at 8 ohms or at 4 ohms. That's important. Okay, so for a given scenario, okay, if you look at the watts, this chart tells you the decibel change in decibels, which is kind of a logarithmic value, relative to 1 watt. So at 1 watt, you are at 0 dB increase, okay, because we're relative to 1. So 1 relative to 1 is no gain, okay. At 2 watts, it's a roughly 3 dB gain. 5 watts, 6.9, almost a 7 dB gain. When you times the power by 10, that's the same as a 10 dB gain. At 100, it's a 20 dB gain, you see? Now at 1,000, you would think it would be 200, but it's not. You can see it starts to get diminishing returns, okay? Now this is not dB as in sound pressure level, SPL. When you think of volume to your ears, that's another whole dB rating chart, okay? But it's the same increase level as this chart, okay? The numbers may not be the same numbers, but the rate at which it's increased is the same. And what I want you all to take away from this is that you can see that as you start increasing your wattage, you start getting diminishing returns on the overall gain, okay, in decibels. So to go from 100 to 1,000 is only a 10 dB change, but to go from 1 watt to 100 is a 20 dB change. So that first 100 watts, there's a big difference in change. And for the next 900 watts is only another 10 dB change, which is very little, okay? And what you'll find out is perceived volume to your ear is the same thing. That's why a lot of people say, oh man, you know, I got a 100-watt amp, you know, and you think that it's so incredible. Well, if you really look, that little SX-750 puts out 50 watts per channel, which is relative to a 1 watt would be 16 point, you know, about 17 dB. To double the power and go to a 100-watt amp, you know, which would be like, I believe an SX, I don't know, 1010 or whatever they call it. There's a 100-watt per channel rating. You're only changing it by 3 dBs. And I will also argue that the perceived volume increase to your ears is going to be the same way. It's going to be a small increase in volume. Okay? Both of these amps will go very, very loud to your ears. And I would even argue that this 10 watts is relatively loud. I mean, to go from 1 watt per channel to 10 gives you a 10 dB gain, which is quite a bit. So you really notice that. But it's diminishing returns as you go up. That's why a lot of people get hung up on, you know, I really need the 100-watt per channel amp, or the 120 or the 150. You know, the SX-1050 amp that we did, which is 120 watts per channel, somewhere in here, with respect to this little SX-750, is not a huge increase in the volume. It's just not. And people are willing to pay an extreme premium to get these amps. And what you find is, you know, when you, for instance, if you look at the SX, and I'm talking Pioneer now just so we can keep everything apples and apples, an SX 750 is right here, and an 850 is right here. It's like 65 watts. And the SX 1050 is right here at 120. So, you know, you're right in here and right in here. I can tell you that the tone control on both of these is almost identical. Okay, the 950 is a little bit, you know, right here, about 80 watts per channel. Okay. Very little differences in actual perceived volume. The circuit design is very similar. I'm not going to say it's identical, but I tell you, the 850, 950, and 1050 and 1250 pretty much all have the same tone control section and preamp section, very similar. The 750, not quite so much, but still similar design, just a little bit less features. Other than that, not a big change. All right? So I just kind of wanted to put that to rest. Okay? You don't have to have the $1,000 receiver to get really good sound and really good volume. You know, you can get the $200 or $300 receiver and just about do just as well. I know there's a lot of people out there that'll probably want to put in their 2 cents on this, but from my experience and from test results and things, I mean, that's kind of my take on this. Okay, now there's so much more to talk about than just that. But if you just want to get into the watts game, watts just isn't everything. Okay, don't get hung up on that is what I'm trying to say. I would rather have a high quality, accurately rated, lower wattage receiver down in here than have a real high watt, you know. I see catalogs today with modern receivers that are rated at, you know, I see these surround sound receivers that are rated at, you know, 7 channels, 120 watts per channel. I mean, that's like 900 watts of power or whatever. you know, and the whole receiver weighs 25, 30 pounds. And, you know, and they're not Class D. A lot of them are just little modules, you know, of normal Class AB modules, you know. There's no way, guys. Sorry. So, all right, enough about this. Let's talk a little bit about RMS and then peak slash IHF slash MPO, which is like maximum peak output. They use all kind of different terms down here, okay? And they are all kind of similar meanings, all right? So first of all, let's talk about these. These are just what they say, and IHF technically had a rating at one time, which is like, what is the peak that the power can hit on a sine wave over a 20 millisecond time frame, okay? And remember, there's 1,000 milliseconds in 1 second, okay? So we're talking a small fraction of a second. RMS, this is the one, this is the gold standard that you should be looking at when you're looking at a rating. And an RMS is basically, if I take an AC signal, okay, and I create a DC equivalent, okay, so the RMS would be a DC equivalent value if you took that AC and averaged it out over a period of time and compared it to a DC level. That is what the RMS voltage would be, okay? So it's a continuous rating over time, okay? Continuous average. And it is much more accurate to what the amplifier can produce than when you get into these games with peak, okay? Now, in order to understand it, we're going to look at it. And I'm going to turn you up to here, okay? And if you notice, I have a couple things set up right now. First thing I've got is I have the oscilloscope set to just one channel because this is going to make it easier. Remember, everything we're doing is 2 channels. And over here I have an analog meter. Now analog meters are kind of interesting because they have a pretty good job of averaging out a signal, you know. They don't bounce around when you're looking at AC. So it's going to give us a decent representation. Now I'm going to have a 1 kilohertz signal, which is the way they normally honestly rate an amp, but we're going to see the way that we can deceive and the way that we can be honest about how an amplifier works, okay? So to help us out with our little experiment, I got my little friend here, the little realistic System 11. It's a STA-11, and in its own right, it's a decent little receiver. It is rated cleanly at 30 watts per channel at 1 kilohertz into 8 ohms. All right, and well, actually 20 to 20 kilohertz it can do 30 watts per channel, and I've tested it and they actually produce what they say, so it's a decent little receiver. Radio Shack, believe it or not, doesn't deserve the bad rap that they get sometimes. A lot of their electronics were produced by a company called Foster or Fostex, which was a pretty decent company. I think they're either out of Japan or Korea, and they were making equipment for a while there that's kind of on par with the Pioneer and Kenwood gear of the time, you know, and Marantz and Sansui and all that. They had some decent stuff, and even the build quality wasn't all that bad, okay? Sometimes they, you know, went to a cost on their lower end things, but even those performed well for what they were. So to explain what we're looking at here, this AC volts, this little red line here, that's the scale we're looking at. I'm on the 10 volt, so when the needle's all the way here, you see the number 10. I'm set to 10 volts, okay? So I'm going to go to about 7 volts here. And why I'm going to go to 7 volts will be a little clearer as we explain all this, okay? So the first thing we're going to do is turn on the amplifier, turn on the outputs, okay? And I'm going to increase this volume, okay? And you can see everything's coming up. And we're going to put about 7 volts up here. Why will be clear in a moment. So right around there. Yeah, I'm pretty close. Okay. So if you look right here, I have 7 volts. And if you look at the scale of my oscilloscope, we have 5 volts per division. That means each graticule represents 5 volts. Okay? And so this is saying 7 volts AC right now, right? But if I look on my scope here, I have 5, 10 volts. And if I go from here to here, it's 5, 10, 15, 20. So wait a minute, if I'm reading 20 volts, why am I only reading 7 volts on my meter? You think there's something wrong with my meter maybe? Or maybe there's something wrong with the scope? Well, the answer is neither. Both are reading totally correctly, but they're both looking at something different. Okay? And that something different we're going to explain right now. Okay? So keep this scenario in mind. We have 5, 10, 15, 20. And from the center, from the 0, this would be 0 volts right here. That's what that little tick mark is. 10 volts going up, 10 volts going down. Okay? And you notice the voltage never is up and down at the same time. It's either up or down. So this is alternating current, right? It's an AC signal. The voltage reading from 0 volts, either end, not both ends, from this to here or from this to here, we refer to that as peak voltage. Okay? So that is your peak voltage. Okay? Very important term. If I measure my voltage from here to here, from this peak, the highest peak in one direction, to the highest peak in the other direction, that would be my peak to peak voltage. Okay, does that make sense? My amp's drifting because I just bumped it. I bumped the volume. Okay? And if I look on my meter is actually reading RMS. Now, how, and it's reading 7 volts. Okay, so if I'm getting 10 volts peak, 20 volts peak to peak, I will get 7 volts, roughly, approximately 7 volts RMS. So this is showing us a DC equivalent of this signal here. Okay, so if I took either of these peaks, either the top peak or the bottom peak, and I averaged it out on this sinusoidal waveform, the average would come out to about 0.707 of this peak. Okay, so if I kind of folded this over and kind of plugged it all together and made a straight line out of this, you would find that it would be about 0.7 volts or 0.707 of a percentage, you know what I mean? 0.707 of a portion of this peak of the sine wave. Okay? Hope that makes perfect sense to you. Now, let's go down and look at a few calculations. If I go down here, I wrote this out ahead of time for you. RMS is 0.707 V peak. If I have 10 volts peak, which was from the zero crossing to the either end of the peak, the positive going or negative going peak, okay? Watts, or your power, okay, equals, and this is just from Ohm's law, is all this is, equals V squared. So you square the voltage and then divide it by how many ohms. Okay, so I have an 8 ohm dummy load, so there it's always going to be 8 in this case, and I'm just going to take my voltage, square it. I'm sorry, I put that down there. V squared divided by 8. So if you look up here, V squared divided by R, 8 ohm load. If I take that 10 volt peak and I want to calculate my watts, I can say that 10 times 10 is 100 divided by 8 would equal 12.5 watts per channel. And remember, I'm only reading half because I'm reading the left channel, but the right channel is doing the same thing right now because I have them both connected to the dummy loads, okay? Just so you know. So technically, this amp can be rated at 12.5 watts per channel, and that's going to be my peak. Okay? Now, if I were kind of malicious, I would say that this amp right now, and I'm pretending, this is a 30 watt amp, I'm pretending right now that this is the maximum power that this amplifier can put out. We're being hypothetical here for a minute, guys, so that we know I don't want to run this amp at its maximum power and overheat it, okay? And I wanted to use round numbers so it's easy for you guys to see how I'm calculating this. If I look at this next one, if I measure peak to peak, 20 times 20 is 400, right, V squared, divided by my 8 ohm load. Now I have 50 watts per channel. And that's peak to peak. Okay? But if I measure it the correct way, which would be a DC equivalent power going into the speaker or into the load, okay, I would have to take this peak and times it by 0.707. And so 0.707 times 10 volts is going to equal 7.07 volts. And if you noticed on our scope, when we have 10 volts peak, 0.707 of that, the DC equivalent, is going to be 7 volts roughly, which is what our meter's saying. So, as you can see, both instruments are accurate, okay? Now, if I take that and I go 7 times 7.07 times 7.07 is going to be 49 point something. So I put, this is a symbol for approximately. So you take around 49 point some volts, which let's round it up to 50. 50 volts divided by our 8 ohm load, guess what? 6.25 watts per channel. RMS. How about that? And it just so happens that that 6.25 is 1/2 of the peak wattage. So when you rate something based on the peak, you will come out with a watt rating double of what the actual RMS value is. So if I wanted to deceive you, I could build an amplifier that's actually a 6.25 watt per channel amp, and I could technically get away with saying it is 12.5 watts per channel peak. Or I can come up with my own term like MPO, maximum power out, or maximum music output, or music power. or maximum whatever. I can use those terms because they're kind of loose terms, and I can say, now I can measure peak to peak, which is 20 volts, right? The positive going and the negative. And I can say now that it's 50 watts per channel. So here's my 6 watt amp, and I'm telling you it's 50 watts. And I can even go one step further. Both of these is per channel. So of course, it's a 2-channel amplifier. It's stereo, right? So I'm going to double that. So that makes this a 25 watt amp. It makes this a 100 watt amp. And it makes the RMS actually a 12.5 watt. But none of these are correct. They're built to deceive, because they know that you're going to think something different. Okay? So that's how I take my 6.25 watt amplifier and tell you that it's 100 watt. Not too fair, is it, guys? But you have that. Whenever you go on eBay and you look at these really cheap amplifiers, and they tell you, well, here's one. Here's a Class D amplifier, and I'm sure you've all seen these. They're all the rage out there right now. There's lots of videos on them. You can buy them on eBay for 20 bucks. The Lafayette LP 2020A Plus, and it's going to tell you that it's 20 watts RMS, but you're really not. And sometimes they'll put a different name with the same amp, and they'll say that the power on it's 200 watts or 100 watts. But when you measure this, you're going to find out you're nowhere near this. First of all, they're not telling you how many ohm load they're running this at. They're not telling you the distortion. They're not telling you, I mean, they're basically leaving out a lot of important information to give you this rating. If you look at the input, this is only rated at 12 volts. And if I use Ohm's law, 12 volts at 2 amps equals 24 watts, right? So if I take 12 volts times 2 amps, I'm going to get 24 watts, because watts equals volts times amps. And if I divide that by 2 for 2 channels, technically that only gives me 12 watts per channel of actual power supply power. But amplifiers are not 100% efficient. Some of this is going to be lost. So in a totally best case scenario, this thing might be able to deliver 10 watts per channel, which is why it's telling you it's 20 watts RMS per channel. Okay? Or 20 watts RMS total, which is 10 watts per channel. If you measure the real output into an 8 ohm load on this, if you get 5 or 6 watts of clean power, you're doing pretty good. I'm just telling you. Test it for yourself. Okay? So, again, back to this. So when we see this 175 watts, let's just do an experiment. And I don't know. I don't really know what these things really do. But if I take 175 watts, 175, and I divide it by 2, right? Right? That is going to be, I'm being too lazy, I should be able to figure that out in my head, 87.5 watts per channel. That's still ridiculous, right? So now if I take that and let's say I go to 0.707 of that. Now I'm down to about 61 watts. Okay? And if I recall correctly, that is a little bit closer to what this thing can do at 4 ohms. And probably at 8 ohms, you're going to be closer to 50 watts. So, again, if they would have just come out and said this was a 50 watt per channel receiver at 1% distortion and called it a 45 watt per channel, you know, at a respectable distortion, you know, 0.3%, let's say. I don't know. I didn't test any of this. But if they said that, I still would say it's a great receiver. I would say it's fantastic. But if you tell me something like this and make my head think that, you know, put a thought in my mind that it's something that it isn't, I'm going to be very, very disappointed when I buy this. First of all, you're not going to buy a 175 watt receiver for $279 even back then. Hate to say it, but these were really, really expensive for a big amp back then, because transistors of that size were really rare and hard to come by and really expensive, because that was kind of a new technology. So I hope this gives you a little insight onto what they're talking about when we talk about watts and we talk about power and all this stuff, and how they come up with some of these ridiculous numbers that they do. It is absolutely possible to deceive you, and still you can't sue them for false advertisement, because they carefully choose their words so that you can't come back on them and say you are lying to me. But it is meant to deceive to a degree. Okay? Again, I'm not ripping on Lafayette. I've owned Lafayette equipment, and I've owned some of this vintage and a little bit newer than this vintage that was really good. I had a cousin that worked for Lafayette Radio Electronics based in Cleveland, Ohio, and you know, some of the stuff that he brought home was pretty high end, really, when you looked at it, but it was nowhere near what it was rated. I mean, it was they rate it like this. You bring it home, it specs out the way I calculated it, and for a 45 watt receiver, it does a beautiful job. It sounds great, worked well, but you know, if they would have just been honest, I think they could have just as easily sold, you know, just as many units. And I don't know, maybe that's one of the reasons these guys aren't around anymore. Maybe not. I don't know. That's, you know, up for debate. But anyways, just a short video, of course I say that tongue-in-cheek, on how this whole power rating thing works. And when you see me do these tests, when I'm testing an amplifier, now I hope you understand a little bit as to why I test it the way that I do. Okay? So, again, if you like this, give me the big thumbs up, and I hope you enjoyed it, and more to come, because I definitely have things ready to go on the bench here. Busy at work still, as always, but anyways, it's been a pleasure once again going on my soapbox and ranting to all of you, and you have a wonderful day, and I wish you all the best, and until next time, so long.